Hello everyone, welcome back to my YouTube channel. Today we are going to discuss some problems on stability. First of all, I'm going to start with a question here. Check the stability of the system with the given characteristic equation using Routh-Hurwitz criterion. We have studied Routh-Hurwitz criterion in our last video. So I'm going to discuss some different problems on Routh-Hurwitz criterion. So I'm going to start with writing a Routh array. So I'm starting to write Routh array, that is starting with the powers of s. Then I'm writing the coefficients, that's the first two rows, 1, 2, 10, 20 and 5. Okay, now we'll move on to writing our next row. So I'm gonna write it, that is 2 into 10, 20 minus 20 divided by 2. What's the answer? It's obviously 10. It's obviously 10. Then I'm gonna write, sorry, it's not 10, I'm so actually sorry, it is actually 0. 20 minus 20 is 0. My mistake. Again, next I'm gonna do the next term, that is 2 into 5, that is 10, minus, there is no term, still 10 divided by 2. That is obviously 5. Now let's check the row that we have obtained. We see that the first element of that row, the row that we have gotten, the first element is 0 and the second element is non-zero. That's an exceptional case. Here the first element is 0, and if all the other elements were 0, we would be solving it in some other ways. Now here the first element is the only 0 element in that row. We are gonna put some value to the first element in that row. That is, I'm gonna change the 0. I'm gonna put something else instead of 0. That's basically what I'm gonna do. I'm gonna put epsilon instead of 0. Because the first element is 0 and the second element is non-zero, it means there is a possibility that the first element could be some value quite next to 0 or something like that. So I'm putting epsilon, which instead of 0 I'm putting here the first element, the third row is 0, but there are non-zero elements in that row. There are non-zero elements. So we are putting epsilon, which tends to 0, in the third row in place of 0. We are putting epsilon instead of 0. Okay, now that I have put epsilon instead of 0, next I'll solve the rest as I always does. The same formula I'm gonna apply. It will be 20 epsilon minus 2 into 5, that is 10, divided by epsilon. Okay, I've done that. Next, the next term will be what we have discussed earlier. That's the last term. It's gonna repeat after every like after one row, it's gonna repeat the last term. So in the last term will also be 5. That is simply I can write it 20 epsilon minus 10 by epsilon into 5 divided by 20 epsilon minus 10 by epsilon. It's basically 5 only. That's why I written 5. Okay, so okay, that's it. Now we have finished our Routh array. The next thing, the main thing that we're going to check is the first column of the Routh array, whether all the elements in that column is positive or not. In order to understand the concept of stability, what I'm going to do is I'm going to mark the first row. Okay, mark the first row, and I've seen a particular term, that is 20. I've seen two major terms here. One is epsilon, the other one is 20 epsilon minus 10 by epsilon. Okay, I said epsilon is a value tending to 0. Let epsilon be a small positive value. Okay, epsilon tends to 0, it is a small positive value. Okay, and if I put a small positive value in this equation, that is 20 epsilon minus 10 by epsilon, it will always be a negative value. For example, I am putting a small value really close to 0, that is I am taking 0.01. Okay, and I am putting it here, and what will happen? This will be 0.01 into 20. What will it be? 0.2. No, it will be just 10 cancelled, and 0.1 into 2 it's 0.2. 0.2 minus 10 by 0.01. Okay, it will be a negative value. Since 10 is greater, it will be a negative value. For any small values that we put, any small values which is so close to 0, that you put in this particular equation will always give you a value which is less than 0, or I could say negative value. So this value will be negative value. So even if I give epsilon a small positive value, the value of the next term will be negative. So I can say that since this term is negative, I can say that there is sign change. All the terms in the first row are not positive. There is sign change. So considering that fact, I could say there are two sign changes, that is from epsilon, positive epsilon is positive, small positive value, from positive epsilon to negative value of the given equation. That is one sign change, and it changes from that negative value to the another positive value. So there are two sign changes. Since there is negative value, we can say the system is unstable. System is unstable. Reason is all the elements in the first row, first column, are not positive. So the system is unstable. Now here said that we can say that there are two sign changes. And hence two roots lie on right half of S plane. Okay, now we have done the first question for our day. I'm going to give you a homework which is a very similar question to this one that we have done. It will give you some practice. Homework question I'm giving you, that is s raised to 5 plus s raised to 4 plus 2s cube plus 2s square plus 3s plus 5 equal to 0. Solve this. It will be something like the question above us. The answer is almost similar, that is there will be sign change and all. You will learn to solve this. This is a very nice question. Everybody please take the time to take a screenshot of this question and do it on your own pace, and just learn. Okay, it is nice, it is easy to solve. Okay, now let's move on to our next question for the day, that is, I'm writing the question, s raised to 6 plus 3s raised to 5 plus, it all looks the same, s raised to 5 plus 5s raised to 4 plus 9s cube plus 8s square plus 6s plus 4. Okay, I have given a characteristic equation, and now I'm going to solve this equation. It is also some different kind of problem from the one we have done earlier. It's kind of different. Okay, so I'm going to write s raised to 6, s raised to 5, s raised to 4, s raised to 3, s square, s raised to 1, s raised to 0. I have written it. Now I'm going to write the coefficient that forms the first row of the Routh array. 1, 3, 5, 9, 8, 6, 4. and the next term is 0. You can write it or leave it. Okay, I'm gonna solve this. So it will be 3 into 5. 3 into 5, 15 minus 9 divided by 3, that will be 2. Next one will be 3 into 8 minus 6 divided by 3, it will be 6. The next term will be 3 into 4 minus 0 divided by 3, that is 4 itself. Okay, we have got the third row of our question. Now we are going to write the next row. So to write that, it is 2 into 9, which is 18, minus 18, that's actually 0. That's actually 0. And the next term is 6 into 2, that is 12, minus 12, it is also 0. Now look at this. Here the two terms in the fourth row are 0. That is, it's not just the first term, it's like all the terms in that particular row is 0. So that's why I said this is a different kind of problem. Our first problem was also different, but there was like only one term. The first term itself was the only term that was 0. But here all the terms in the given row is 0. So how are we going to solve it? It's very simple. We'll form an auxiliary equation. Auxiliary equation. We are going to form an auxiliary equation. I'm writing it as A of S. From the row just below the one which is a 0, we got a row with full zeros. So what I'm going to do is I'm going to form an auxiliary equation with using the elements of the row just above it. So I'm taking this row into consideration, and I'm gonna write an auxiliary equation using this. It is s raised to 4. It starts with s raised to 4. So I'm gonna write it like 2s raised to 4. The first term is s raised to 4. And the second term will be, as we had written in a zigzag pattern, I'm saying, if this is s raised to 4, then this might be s raised to 3, and this might be s raised to 2. So I'm writing 6s raised to 2. Similarly, this all the terms in this particular row is like even powers. So s raised to 4, s square, and s raised to 0. So that will be 4. That will be just 4. Okay. I have written the auxiliary equation. Now the next step, what I'm going to do is I'm going to take the derivative of the auxiliary equation, that is d by ds of A of s, which gives me 8s raised to 3 plus 12s plus 0. Constant derivative of a constant is 0. So I'm not considering this. Okay. Then I've got the derivative as 8s square plus 14. On simplifying this, we could get 2s square s cube plus 3s. Okay. On simplification, I got 2s square plus 3s. S cube plus 3s. Okay. I have gotten another equation from the third row. I got a small equation which starts with s cube. So what I'm going to do is I'm going to replace this particular row which has all the 0 elements. I'm going to replace it with the values of the equation that I have gotten. After taking the derivative, I got an equation, right? So I'm going to take the elements of that particular equation and put it in the 0 row containing 0 all elements as zeros. So I'm going to put that equation over there. That is, I'm rewriting the Routh array once again. That is, I'm starting with s raised to 6 and s raised to 5. This 3, 9, 6. I'm going to go write s raised to 4, which is 2, 6, 4. Okay. Okay. Now we have gotten an equation here, and I'm going to put that coefficients into the equation. That is 2s cube plus 3s. Okay, I've gotten two values here. Now I'm going to solve this whole equation. Okay, like I usually do. I'm going to solve it like 2 into 6 is 12. 12 minus 2 into 3 is 6. That is 6 by 2. 6 by 2 is 3. I'm going to repeat it. That is I'm gonna do this here. 2 4s are 8. 8 by 2 is 4 itself, right? 4 4 4 here itself. And what will this value be? This will be 9 minus 8 is 1. 1 by 3. And the next value, what will it be? It's obviously 4. So I have written the Routh array for the given question. For our question, I have written the Routh array. Now what I'm gonna do is what we does as usual. That is checking the terms in the first column. Okay. Now that I see the first column of the Routh array, all the terms in this column is positive. So from that, I could say that the system is stable. Here, all the terms in the first column of Routh array is positive. Hence, the system is stable. Hope you all understood what we have discussed today. We have discussed two problems, which is kind of different from the usual problem, and I have discussed it. I hope you all understood these two problems. If you don't understand it, watch it 2 or 3 times. You will get it, and do the homework. You will get more practice and all. So thank you so much for watching my video. If you like this video, please like and subscribe to my channel. And thank you for watching.